Hi viewers, Olaniwaju Bolaniwa is my name. Teaching is my calling. What we have for today, quadratic equation. Here we are going into the intermediate level of the quadratic equation, where we shall be solving questions related to quadratic equation by using completing the square method and formula method. But before we move into the completing the square method proper, let's try to work on this. For instance, we have this expression x squared plus 6x. What must be added to this to make it a perfect square? As it is now, we cannot factorize it in a way that it will be a perfect square. So the procedure to solve it in a way that we will generate a perfect square, all we need to do is to pick on the b, like we did in the previous class. The coefficient of the one that has square is a. The one that has alphabet is b. Whereas the third one, if it has the third one, that's when it becomes a quadratic equation. If it has the third one, that one is the c, constant. So what we are going to do here to make this expression a perfect square is by finding the half of the b and squaring it. By the time we do that, it will become a perfect square. So what do we have here? This 6 is the b. So we are going to pick it, get the half of the b. And half of the b, which is 6 here, is 3. So we say 6 all over 2, which is going to be 3. We are getting the half of the b. Then the next thing is to square the half of the b, which is going to be 3 raised to power 2. And 3 raised to power 2 is going to be equal to 9. So this is our constant c. What must be added to this expression to make it a perfect square? Now we can now add it like x squared plus 6x. Now what must be added to this to make it a perfect square? We now add it to be 9. We have 9. This is the value we are going to add to this to make it a perfect square. Now if we want to complete the whole square, this we can index it to become x squared plus 6x then plus 3 raised to power 2. 3 raised to power 2 is still the same thing as 9. Then this one has the square, this equally has the square. We group them together, and when we group them together, we put it in bracket, then we square it. By that, we have completed the square. We pick on the x, we are coming back to the square here. We pick the x, and we have the 3 here, plus 3. We close the bracket, then everything together, we have it as square. This is going to be our foundation towards the completion of the square method that we shall be doing later in the class. So having this is also equivalent to what we have here. By the time you expand this bracket, so for the benefit of that, let's try to expand this bracket. So expansion of this bracket means we are having x plus 3 as it is squared, again x plus 3. So opening this bracket, x multiplied by x, we are going to have x squared, x multiplied by 3 will give us 3x. Furthermore, x again, x multiplied by this give us this, x multiplied by this give us this. Now 3 multiplied by x, we have 3x. And finally 3 multiplied by 3 will give us 9. So when you sum the like terms together, we are going to have x squared 3x plus 3x is going to give us 6x. So we have 6x, then finally our 9. Let me take you into another example using the completing the square method. Here is another one. Let's see what will happen. The b is minus 1 all over 3 all over 5. So when we want to work on this, let's turn it from being a mixed fraction. We have 5 multiplied by 1, 5. Then 5 plus 3 will give us 8. We have minus 8 all over 5. This is our b. As it is our b, because the b will not have u. The b is just the coefficient of the one that has alphabet without power. As we have the b to be this, the next thing is to find the half of the b. What is the half of this? As it is a fraction, all we just need to do is to multiply it by 1 all over 2. The one we did earlier here, the half of 6, we quickly found it to be 6 all over 2. Of course, if we choose to say 6 multiplied by 1 all over 2, it's still the same thing, because 2 here 1, 2 here 3. So as it is in fraction, all you just need to do is to multiply it by half. And when you do that, 2 here 1, 2 here 4, we have minus 4 all over 5. That is the half of the b. On getting the half of the b, we are going to square the half of the b and add it to the expression given to us here. So we now have the minus 4 all over 5. We are going to square it. Let's square it right here. We have minus 4 all over 5, everything to be squared. So to square this, we are going to have minus 4 raised to power 2 will give us 16. Then 5 raised to power 2 will give us 25. So this is what we are going to add to the expression given here before. We have u squared minus this one already established as an improper fraction, 8 all over 5, then plus 16 all over 25. So in order to complete the square perfectly, we are going to use this. This is what we are going to add to the expression to make it a perfect square. So we have u squared minus 8 all over 5. Sorry, I left the u here. So the u will be here. So we have 8 all over 5 u, then plus minus 4 all over 5, everything raised to the power of 2. So this is having a power of 2. This is equally having the power of 2. We are going to group them together to become u. Then what do we have here? Minus 4 all over 5, everything raised to the power of 2. We have made it to become a perfect square. Easy. Now we are going to solve the 4 questions we solved in the earlier class where we used the factorization method. This time around we are going to use the completing the square method. Now let's go into the formula for solving quadratic equation. So for formula for solving quadratic equation, we are going to implement the completing the square method, which will generate the third method, which is the formula method. So starting from that, we are going to get a skeletal representation of how a quadratic equation is presented. So let's assume that we have a as the coefficient of our x squared, then plus b, which is the coefficient of the x without power, and c to be our constant, then finally equal to 0 to make it an equation. So the very first step you are going to take while using a completing the square method is to divide everything all through by the coefficient of x squared, which is the a. We divide everything all through by a. So by the time I divide this one by a will cancel a. I will left with x squared. As for the b, we are going to have b all over a x, then plus c all over a equal to 0. That's the first step. Then on to the next step, we are going to move our constant to the right side. So moving it, we make it to become x squared plus b all over a, our x given, then C over A coming to this side, the sign will change. Then as the sign changes, it becomes C all over A. From there, the next step is to now think what must be added to this equation to make it a perfect square. Remembering how we did it earlier, it's going to be our B multiplied by half, then we are going to square it. So I'll quickly make use of this place. For us to get half of B all over A is going to be B all over A multiplied by 1 all over 2. This will result to B multiplied by 1, B, then A multiplied by 2. We are going to have 2A. Technically, B all over A, the half of B all over A is going to be B all over 2A. This is our value here, of which we are going to square it. That is what will be added to this to make it a perfect square. So we proceed to that. X squared plus B all over AX. So what must be added to this to make it a perfect square? It is this. We have plus B all over 2A, which we are going to square. So whatever we have here that has been added here will equally be added to the right side, which is B all over 2A. We do it to the right side too. So I can choose to place my B all over 2A before writing the minus C all over A. So it means we are going to have B all over 2A squared. Then we have minus C all over A here already. Minus C all over A. Now, the next thing is to complete it. To complete the square here. We have the square here given. We have the square given here too. So we are going to group them together, which will give us, we write only X and we write B all over 2A plus B all over 2A. Everything in bracket, and we are going to square it. As for this side, the two are not having square. We cannot complete the square in such case. All we need to do here is to apply the square for the numerator and the denominator. So when we do that, B raised to power 2 will give us B squared all over 2A raised to power 2 will give us 2 raised to power 2. That's going to be 4. And A raised to power 2 will give us A squared. Upon having the 4A squared, we have our minus C all over A. We have fraction to work with here. So we are still having our X plus B all over 2A, everything raised to power 2, to give us the LCM of 4A squared and A will be 4A squared. Now, 4A squared divided by 4A squared will be 1. 1 multiplied by B squared, we still have our B squared intact. As for this, 4A squared divided by 8, it's like having 4 times A times A, everything divided by A. A will cancel A, you will be left with 4A. So, 4A squared divided by A will give us 4A. The 4A multiplied by C will give us 4AC. We have minus 4AC. Having done that, the next step will now be to remove the square. And removing the square will mean we are going to square root the other side. So this will give us X plus B all over 2A equal to plus or minus, because we are dealing with quadratic equation, of square root of B squared minus 4AC, everything divided by 4A squared. So having this, the numerator, we cannot find the square root of this because it's not perfect square. As for the denominator, we can find the square root of this. So finding the square root of this will result to having, let's write this, plus b all over 2a equal to plus or minus. The square root of the numerator cannot be found. We still keep the square root intact for the numerator, which is b squared minus 4ac. As for the denominator, we can find the square root of that. The square root of 4 is going to be 2, and the square root of a squared is going to be a. So because we have found the square root of the denominator, the square root does not cover the denominator. Moving further, we are now going to collect the right terms in such a way that we make x subject of the formula. So making it subject of the formula here will give us x, the b all over 2a will move to the right side. Now we have an equal to, by the time the b all over 2a moves to the right side, the sign will change. So it becomes minus b all over 2a. So we have the plus or minus given. Plus or minus the square root of b squared minus 4ac divided by 2a. As we have the base, or as we have the denominator to be the same, so we are going to make it result to the denominator, the LCM of the 2 is going to be 2a, of course. 2a divided by 2a, we have 1. 1 multiplied by b minus b, we have minus b. 2a divided by 2a, 1. 1 multiplied by everything at the numerator position becomes the same. So we have plus or minus the square root of b squared minus 4ac. This is going to be the master formula, which we call the almighty formula, or the formula method of solving quadratic equation. Upon getting our formula method, we are going to implement the completing the square method to solve the questions we solved in the previous class of this quadratic equation, where we used the factorization method to solve these 4 examples. These were the answers we got using the factorization method. Now let's see how the completing the square method will generate the same answers as to what we have gotten here. So we start with the question number 1, which the answer we got was minus 9 or minus 2. So starting with the first question, using this process, because this process was not just given, it generated the formula method, which we are going to go into after completing everything on completing the square. So to start with, the first step is to divide all through by the coefficient of x squared, which is a. But here we have our a to be 1. So there is no point dividing everything by 1. So we see how everything intact. Then the next step after doing this is to move our c to the right side. Then what is our c here? 18. So we are starting from that point. X squared plus 11x equal to minus 18. We have moved the c to the right side. Now to the next step is to find the half of the b, square it, then add it to the equation from the left and to the right. So the half of 11 is going to be 11 all over 2. We are going to have x squared plus the 11x. Now what are we adding to it? We are adding 11 all over 2, which we are going to square upon getting the half of the b. which is 11 over 2. We are going to square it. That's what we are adding to the left side and also to the right side. So this same value here again, I'm saying equal to, I'm adding it to minus 18. I can choose to say minus 18 plus 11 all over 2 squared. At the same time, I can choose to write 11 all over 2 everything squared. Then what do we have here? Minus 18. It's still the same thing. Now from here, when we choose to complete the squares, we are going to pick this and this. We group them together in a bracket, then we square it. So this gives us x plus 11 all over 2. Then we open bracket, then we square it by this side. Now to this side, which is 11 all over 2, we are going to square it. By the time we square the 11, it gives us 121 all over the square of 2 will give us 4. Then we have minus 18 all over 1. As we rightly did for this place, when we squared it, then we carried out the addition or summation of the two fractions. So that's what we are going to do next. We see have our value here intact. X plus 11 all over 2, close bracket, raised to power 2, all to give us LCM of 4 and 1 will give us 4. And 4 divided by 4, we have 1 multiplied by 121, we have 121. So 4 divided by 1, we have 4. 4 multiplied by 18, that's going to give us 72. So we have 72 here. So we still have this one intact. X plus 11 all over 2, everything raised to power 2, equal to 121 divided by 72. 121 divided by 72, that's going to give us 49. We have 49 all over 4. Upon having this, we are going to remove this square. By the time we remove this square, it's going to result to square root of the right side. So that gives us x plus 11 all over 2 equal to plus or minus square root of 49 all over 4. So x plus 11 all over 2 equal to plus or minus the square root of 49 is 7 and the square root of 4 is 2. So we collect the like terms by making x object of the formula. 11 all over 2 will move to the right side. So by the time this moves to the right side, the sign will change. So we have x to be equal to minus 11 all over 2 plus or minus 7 all over 2. So what is going to be our x? We are going to share them. We are going to share it in such a way that they will stand separately. So this will give us minus 11 all over 2 plus 7 all over 2. That's a condition. Or x is going to be minus 11 all over 2. Then the second option, minus 7 all over 2. So let's see what happens next. X is going to be, by the time we check the denominator, there are 2. So we have it just 2. So minus 11 plus 7. I'm owing 11 and I have 7. So by the time I pay the 7, I'm going to be left with minus 4. This gives me minus 4. Or here we have the denominator to be the same. Minus 11 minus 7. Owing 11 and owing 7. What I'll be owing in total will be 18. So this gives me minus 18. Now what will be the x value using the completing the square? Minus 4 over 2 will give me minus 2 or x to be equal to minus 18 all over 2 will give me minus 9. Minus 9. Easy. But by the time you check it with this, you see that the answers are the same. Let's go to the second example. Now to the second example I'm going to solve using completing the square method. I'm going to pick, I'll pick on this question number 3, and I will leave you to use completing the square to solve the question number 2 and question number 4 using completing the square method. So I'm picking on the third example here, of which the answer we got by using the factorization method was this. So let's see what we'll have for the question number 3. So solving the question number 3, let's try to treat this again. X multiplied by x, we have x squared. Then x multiplied by 1, it will give us an x. For this side is equal to 2 minus 5x squared. So the next thing is to collect the like terms. The x squared, which is minus 5x, will come to the right side. Then the sign will change to addition. So we have 5x squared. Then we have an x squared here already. Then plus the x and the 2 coming to the right side, the sign will change to become minus 2 equal to 0. This is x squared, this is x squared. We have 5 of x squared plus 1x squared. It gives us 6x squared. 6x squared plus x, then minus 2 equal to 0. Now, we are going to proceed using our favorite completing the square method for the purpose of this class. For completing the square method, the first step is to check what is the coefficient or what is the value of a. The a is 6. We are going to divide everything by 6. So when we do so, this one divided by 6 will cancel 6. We have x squared plus this place is going to be x all over 6. Or we can say 1 all over 6x. It's still the same thing. Then finally for this place, we have minus 2 all over 6. Of course, minus 2 all over 6 will result to minus 1 all over 3. Because 2 goes here 1, 2 goes here 3. So I'm writing minus 1 all over 3, all to give us 0. Let me clear this. Upon doing that, the next step is to move our c to the right side. So I'll do that. X squared plus x all over 6 equals 1 all over 3. From here, we are going to find the half of b as we have been doing earlier. So the half of b here is going to be, or let's start with how do we identify the b. The b is just going to be 1 all over 6. How is it so? The coefficient of x here is 1. So we have 1 all over 6. So what is the half of this? The half of this is going to be 1 all over 2. So by the time we multiply this together, 1 multiplied by 1, we have 1 all over 6 multiplied by 2. It gives us 12. But the intention is to find the half of the b, square it, then add it to the left and to the right. So we have gotten our b, which is 1 over 6. We have gotten the half of it, 1 over 12. Now let's square it. So to square it, we have it raised to power 2. This value will be added to the left side and to the right side of the equation. So moving on, we have x squared plus x all over 6. Now plus this, 1 all over 12 raised to power 2 equals 1 all over 3. Then plus 1 all over 12 raised to power 2. Let me rub off that please to avoid confusion. We move on. We have the perfect squares here. We pick them together in the same bracket and square it. X plus 1 all over 12, everything raised to power 2. As for this side, 1 all over 3, 1 raised to power 2, 1 times 1 is 1. We see how it as 1. All over 12 raised to power 2 will give us 144. We have 144. Let's keep writing this for now. 1 all over 12, everything raised to power 2. Equals to the LCM of 144 and 3 will be 144. Yes, we have it as 144. So by the time we divide 144 by 3, that should give us 48. We have 48. This is 48. Then plus 144 divided by 144, we have 1. Then 1 multiplied by the numerator, which is 1, we also have 1. Moving on from here, let's write this once again. X plus 1 all over 12, all raised to the power of 2, equals 48 plus 1. That gives us 49 all over 144. It's getting shaped now. So the next thing is to remove the square. So by removing the square, it will result that to the fact that the right side will become a square root. X plus 1 all over 12 will give us plus or minus, we should not forget that, of square root of 49 all over 144. Then we do it. X plus 1 all over 12 equals plus or minus the square root of 49, we have it as 7. The square root of 144, we have it as 12. That's 12. Now, let's carry out the next level, which is x equals 1 all over 12 will move to the right side. So by the time the 1 all over 12 moves, it becomes a minus. So we have minus 1 all over 12. Then plus or minus 7 all over 12. It's time to use the next place. So what will our x give us from here? We share. So we have x to give us minus 1 all over 12. Let's start with the plus. Plus 7 all over 12. Or x gives us minus 1 all over 12. Then the second option, which is the minus, minus 7 all over 12. 7 all over 12. Now, let's read the first one. Thank God, the denominators are the same. So we just treat it clearly by having everything as 12. 12 divided by 12, 1. 1 times minus 1, which results in 60. Minus 1, then plus 7. Or x should be, the denominators are the same. We have 12 stated already. So minus 1, then minus 7. What will our x finally be? Minus 1 plus 7. We are only 1, we have 7. So we are going to add 6 because only 1, only 7, you have 6. So that's going to be 6 over 12. Or the x to give us minus 1 minus 7. I owe 1, I owe 7, I owe 8. So I have minus 8 all over 12. Let's try to reduce this to the lowest form. 6 here 1, 6 here 2. Or minus 8. What is the highest common factor in this? We have 4. So 4 goes here. 4 goes here. 2. And 4 goes here. 6. 4 goes here, 2. 4 goes here, 4 goes here, 3. So from this, we cannot cut it further. Let's compare it to what we had when we use the factorization method. For the factorization method, we had minus 2 over 3 or 1 all over 2. Of course, 1 all over 2 or minus 2 all over 3. Easy. Wow. Having done this, I believe you have gain one or two knowledge about using completing the square method to solve quadratic equation. Deliberately, I have left the question number 2 and question number 4 for you viewers to solve. Take a shot of it and put your answer at the comment section below. And don't forget to subscribe to this channel, click like on this video, and share this video with your loved ones, your colleagues, and your friends. Thank you so much. Till when next we meet, we should be at the advanced level of the quadratic equation. There we shall be treating quadratic equation by using the method of formula method. Upon using the formula method, we are also going to move into the word problems leading to quadratic equation. Can't wait to see you next time. Until then, stay blessed.